These 5 slides from chapter 18 introduce this new type of compound called a carboxylic acid, and it features this thing called a carboxyl group. Now in the last chapter with aldehydes and ketones, we saw that C double bond O, that's the carbonyl, but if you also have this OH group on it, then all of this together becomes a carboxyl group. And as it says here, the 4th bond to that carbon can be as simple as another hydrogen, or it can be a chain, a ring. It can be as simple or as complex as you might imagine. And so we're going to be talking about reactions that involve the carboxylic acids. And so like any type of compound we've seen before, we want to be able to put names with these. And so here are the 4 simplest carboxylic acids. Their names are actually the 2 words. It's something and then acid. And in the official IUPAC name, you can see the suffix that you can pick out is OIC. So methanoic is the 1-carbon carboxylic acid because it's considered to be related to methane. Ethanoic for the 2 carbons, then we have propanoic and then butanoic, and beyond there we have pentanoic, hexanoic, and so forth. Like aldehydes, we don't have to use a number in the name because the carboxyl group has to be at one end or the other. It's traditional to see it on the right-hand side of the chain like you do here. These alternate names are used, especially for these first 2, very often. So just as we saw with aldehydes and ketones for that matter, sometimes there's more than one common way to refer to these. Formic acid is the older name for methanoic acid. Formic comes from the Latin word for ant, which is formica, and that's why the ant is pictured on that slide from a couple of minutes ago, because this is the kind of acid that ants use to defend themselves when they bite you. We're most familiar with acetic acid. That is the active ingredient in vinegar, and ethanoic acid is simply its more formal name. And then we have propionic as an alternative to propanoic, and then butyric. Butyric acid, by the way, is the worst smelling of these. That butyric comes from the word butter. When butter goes rancid and has that terrible odor, it's because it's producing butyric acid as it decomposes and degrades. So our nose certainly knows what that smells like. Vinegar is not exactly a wonderfully pleasant odor, but it certainly smells better than the 4-carbon carboxylic acid. By the way, these condensed formulas, this COOH is kind of a traditional way that this gets abbreviated in older textbooks, especially back before they could typeset double bonds to really show the detail here. We would assume that these oxygens are not just simply singly bonded between the carbon and hydrogen, because this carbon here, it would not have enough hydrogens if all of that was just a single bond. So we assume there has to be 4 bonds to that carbon, just as always, and so that one of those oxygens represents the carbonyl oxygen. But you do still see that even in your textbook, this COOH, so that kind of is, again, a little bit of a shortcut for drawing out the full structure. There's not alternate names for every acid. The IUPAC system, though, provides an appropriate name for an acid of any carbon chain length. Anything we call an acid tends to have these properties, and in the world of organic chemistry, we don't have a whole lot of hydrogens that are capable of creating these effects, and it's the ionization to produce hydrogen ions that makes things an acid, at least most of the time. And so all of these properties are common to carboxylic acids, and so they have this in common with things like hydrochloric acid or sulfuric acid, some of those inorganic acids that are commonly used. We're familiar with citric acid that comes from citrus fruits, that tangy flavor that you get from lemons and oranges. Our taste buds are sensing that sour taste because those are examples of acids, and in fact organic carboxylic acids as well. And all of these properties are really due to this equilibrium here. I'm showing the ethanoic acid or acetic acid as the example, and that pink hydrogen is the one that ionizes when you put this in water. That's what's responsible for all of those properties on the last slide. It's the presence of free hydrogen ions doing their thing. And we've seen certainly a lot of hydrogen in the world of organic chemistry, but up until now we haven't talked about compounds where that would form an ion when you put it in water. And so this class of compounds, they're famous for doing that. A simple alcohol doesn't do that, at least not in plain water. Hard to get the OH to break apart for an alcohol. Aldehydes do not do this, they are neutral. But these kind of compounds definitely have this kind of acid behavior that dominates their chemistry. So we're going to see these in action in the next chunk of material that you'll be talking about. And at least at this point we can put some names and structures together for these acids.